at exercise 1103, the capture-recapture technique. We're now looking at sampling and populations, all right, how to sample a population. Now, the capture-recapture technique is a way of estimating the size of a population. The technique was first applied to the study of fish and wildlife populations to monitor the size of fish and wildlife populations, okay? It's used in the fishing industry to estimate fish population in rivers, lakes and oceans, and to monitor the number of each species that can be caught for commercial sale. You know, we don't want to overfish certain breeds so that they don't become extinct, etc. The capture-recapture technique involves capturing and tagging a sample of animals from the population, then releasing them back into their environment. So let's see, we've got this big diagram up here of the population. We take a sample, we have the population. What they do is they first collect some fish from the population, they tag them, they then release them. A week later, a month later, whatever, sometime later, they take a new sample and they will find a certain proportion of that population was tagged from the initial tagging. So what they do, first time they go out, they might catch 20 fish and they tag them all. They release them. They might go back a few weeks later and they might catch some fish, maybe 10, and they see how many of those are tagged. That means that they're able to estimate what the total population is. All right? All right, now, the way we estimate the population is using equivalent fractions, since both the captured and recaptured samples are representative of the population. I think as soon as I do a question, you'll understand, all right? So, first question, exercise 1103. From a lake, so there's a lake, 100 rock lobsters were caught. So, everything that's caught the first time is tagged and put back into the lake. So 100 rock lobsters were caught, tagged and returned. Of course, there's more than 100 lobsters in the lake, right? They came back 6 months later and took a sample of 80 lobsters and found that 11 were tagged. So what I'm going to do, let's look at the second sample. How many are tagged out of the total in the second sample? 11 out of 80. So I've got tagged over the total. It's always tagged over the total. I know that that's 11 out of 80. Okay, don't put an equal sign here yet. So I want tagged over the total. In my second sample, 11 out of 80 were tagged. In my first sample, how many were tagged? 100 out of X. I don't know how big. In my first sample, I collected 100, but there could be thousands in there for all I know. So the ratio of tagged over total, in my second sample, it's 11 over 80. That ratio should equal 100 over X, because I don't know what the total population is. So tagged 11 out of 80 in the second sample equals 100 tagged in the first sample over X. I don't know what X is. There's obviously more than 100 rock lobsters in the lake. Now I solve that. So it's tagged over total. So, second tagging, like second catch, was 11 out of 80. Do you get it? First catch, I tagged 100 over X. I don't know how many there are in the whole lake. So now I have to solve this equation. Now the X is on the bottom. What do we do to both sides? Flip both. 80 over 11 equals X over 100. So flip both sides. You flip both sides because the X is on the denominator. When you solve for X, you don't want it on the denominator. Now, how do I get X on its own? At the moment, it's X divided by 100. What's the opposite of divide by 100? Times 100. So, X, therefore, is 80 over 11 times 100. So, we want X on its own. At the moment, it's X divided by 100. So the inverse operation of dividing by 100 is to times 100. So 80 divided by 11 times 100 gives us 727. Okay, let's try another question. Okay, so first catch, second catch, all right? To find the possum population in New Zealand, Otago's province, 800 possums were caught, fitted with a microchip and released. So my first catch, I've got 800 out of, I don't know what the total population is, over X. Does it make sense? Okay. With my second catch, so some months later, they caught, it says 45 out of 640 possums were found to have a microchip. How many did they catch in the second catch? 600. They caught 640 and 45 were tagged. So second catch, 45 out of 640 are tagged or microchipped. So how do I set it up? Tagged over the total. Now I'm going to do the one with X first, all right? Or I can do the other one, it doesn't matter. 45 over 640 equals 800 over X. Do we know what to do? Flip them both. You have to have the X on the numerator. Are we good? So 640 over 45 equals X over 800. How do I get X on its own? The inverse operation of dividing by 800 would be to times by 800. And so X is, well, it's going to be pretty big. I reckon there's like 10,000 or
11,000.
Yeah. 11,000.
377.7 bucks.
Approximately, let's just go 11,378. 11,300. Oh, they want to the nearest 100, sorry. Estimate to the nearest 100. 11,000 to the nearest 100. 377 is closer to 400. So we're estimating it to be 11,400 possums. Okay. So 200 tiger snakes were captured on a property. They were marked with blue dye and then released. So your first one is 200 out of X, yeah? Now, when a random sample of snakes was taken, this is sometime later, they found that 51 out of the 110 snakes captured had the blue mark. So they're our two fractions that we put equal to each other. Now, the local snake catcher estimated that there are 400 tiger snakes on the property. Don't worry about that. You need to see if your answer is 400 when you do this. Don't use the 400, okay? So I think it's about right. Because, yeah, I think it's about right. So I can either put 200 over X equals 51 over 110 or 51 over 110 equals 200 over X. Do you want me to put the X one first? Yeah. So I've got 200 over X. Remember, it's tagged over the total population. So 200 over X equals 51 over 110. What do? I flip both sides. I need the X on the numerator. So X over 200 equals 110 over 51. So X is 110 over 51 times 200, which is?
431.
Yeah, I think it's fairly close. He's off by about 30. Yeah, that's not a bad estimate. Yeah, but it's approximately 431. Look, I think it's a pretty good estimate.
Well, it's under.
I'm going to put it is a fair estimate. He's like 30 off. 30 out of 400 off.
So what are you saying?
Well, if you want to see how accurate it is, the difference between his estimate and yours is 31, isn't it? 31 out of, there's actually 431 on the property. I'm just seeing his percentage correctness. Do you know what I mean? Yeah. He's off by 31 out of 431. Yeah, that's not too bad. 7% off's not too bad for estimating a population. If you're 50% off, that's bad. So it's a fair estimate, okay? All right, now, I wouldn't say it's very accurate, like it's fair. Just say it's a fair estimate.
So it's not correct, but it's a fair estimate.
It's not, no, it's a fair estimate. He thinks there's about 400 snakes. He's about right. There's 430. It's different to saying there's 4,000 snakes. Do you know what I mean? He's fairly close. Yeah, okay. All right, next question. The capture-recapture technique was used to estimate a population of seals in 2012. Worth 2 marks, 2012 HSC, question 26F, right? 60 seals were caught, tagged and released. So 60 were tagged out of X. Are we okay with that? Later, 120 seals were caught at random and 30 of these 120 were tagged. So 30 out of 120 were tagged. So let's start. So we've got tagged over the total. All right, do you want to do the X one first or the other one first? All right, so we've got 60 over X equals 30 over 120. You know, I can already see the answer by using equivalent fractions. How do you go from 30 to 60? Times 2? The answer is 240.
Yay.
Just by looking at fractions, you know. Look, how do you go from 30 to 60? Times 2? 120 times 2 is 240. But let's just flip both sides. X over 60 equals 120 over 30.
It's 240.
What's 120 over 30, girls? What's 120 divided by 30? Anyone?
40.
It's 4, but I'll just write it. 120 over 30 times 60, and it's 240. So that's the estimated population.
Wait, what about the 11%?
Oh, we're not finished. Right. So it says 30 of these seals had been tagged. Now that is in 2012. Is that right? Yeah. So the recapture technique was used to estimate a population of seals in 2012. This happened in 2012. In 2012, we think that there were 240 seals in total. We okay with that? But then it says this population of seals is 11% less than the estimated population for 2008. So this number is 11% less. Now, if you decrease by 11%, we have to use the unitary method here. So I'm just going to put this here and get rid of this over here. Right. Now, this is 11% less than what it was. So this is in 2012. Now, if you decrease by 11%, what percentage do you have? 89%. So this 240, we're using unitary method, is 89% of the population that there was in 2008. So we say 89% is 240. So this is the estimate in 2012. This estimate is 11% less than what it was in 2008. So in 2008, there must have been a bigger number. If you decrease by 11%, your new number is 89% of what it was. So 89% is 240. What do I do now? Unitary method. I need to get to 100%. How am I going to get there? Divide by 89. 1% is, and then I'm going to times by 100. Do you remember this? It's a bit tricky, girls. So I'd say this question, 1 mark to get you 240, 1 mark to do the next bit. So what's 240 divided by 89? It's 2 point something, etc. Dot, dot, dot. And times that by 100, and you get 269.629, etc. Double 629. Well, what does that approximately equal? 270? So it's approximately 270 in 2008. That's your estimated population. Now, to check your answer, if you do 11% of 270, I think you'll get about 30. So if you want to check that answer, let's just check. What's 11% of 270? I think you get 30. Sorry? Yeah, which is approximately 30. Approximately 30. And 270 minus 30, that gives me that 240 population in 2012. So the population numbers were higher in 2008. We're estimating 270. I'm going back to check my answer. If that decreased by 11%, so we lost 30 seals. So now 270 minus 30, 240 is what we did have there before. So the answer here is 270 seals. That was the estimated population for 2008. Okay, now for 2007, question 23. This is worth 3 marks in total. So a scientific study uses the recapture technique. In the first stage of the study, 24 crocodiles were caught, tagged and later released. So 24 out of X were tagged. Later, in the second stage of the study, some crocodiles were captured from the same area. 18 of these were found to be tagged, which is 40% of the total captured during the second stage. So what they're saying is that 18, so 18 out of, it's some number that we don't know as well, but that 18 is 40% of the total. So that 18 is 40%. Now, the first question is, how many crocodiles were captured in total in the second stage? We know that the 18 represents 40% of the catch. Do you agree with that? 40% of the second stage caught. I have to use unitary method to get 100%. So I'm going to write 40% is 18. Instead of going down to 1%, can I just go down to 10%? Or drop down to 20 and then up to 100? I need 100%. How am I going to get to 100%, girls? Yeah, or I can divide by 4 and times 10. We can divide by 40 to give me 1% times 100. Can I do it in one step? Divide by 40 times 100. What do you get? 36 and 9. It should be 45. Okay. It's 45. So part 1, how many crocodiles were captured in total during the second stage? It's 45. Because those 18 crocodiles represent 40% of the population. So I need to know what 100% or the entire population is in that second capture. So now, part 2, calculate the estimate for the total population. So now I know that this second catch, so the first catch is 24 over X. The second catch I now know is 18 over 45. All right? So, we ready? We just set it up like normal. Calculate the estimate for the total population of crocodiles in the area. So I've got 24 over X equals 18 over 45. What do I do? Flip. X over 24 is 45 over 18. X is 45 over 18 times 24. 60.